When we are working with the very large or very small numbers that frequently occur in science, scientific notation provides a useful way of writing numbers. Scientific notation for a number is an expression of the type n times 10 to the power of m, where n is at least 1 but less than 10. In other words, we have one non-zero digit to the left of the decimal place, and m is an integer. Converting from scientific to decimal notation involves multiplying or dividing by a power of 10. When m is positive, the decimal point moves right m places in the decimal notation. When m is negative, the decimal point moves left, the absolute value of m places. We generally try to perform this multiplication mentally. Here we have two examples of converting numbers that are in scientific notation. Notice the single digit to the left of the decimal place, and converting them to decimal notation. Since the exponent is positive, the decimal point moves to the right. So the decimal point is originally here between the 3 and 8. We will move it 5 places to the right. If we run out of numbers, we'll put zeros for the placeholders, moving 1, 2, and then the 3, 4, 5 for the remainder. We have an equivalent value to this scientific notation of 381,000. In the next problem, since the exponent is negative, the decimal point moves to the left. So in decimal notation, we'll move our decimal to the left 4 places. Here's 1. We've run out of place values or powers of 10, so we'll add zeros and continue on, which gives us the decimal notation equivalent to the scientific notation of this number of 0.00024. To convert from decimal notation to scientific notation, the procedure is reversed. We want our decimal to have an integer between 1 and 9 inclusively, and right now we have 0. So we're moving it 1, 2, a total of 3 places to the right, and to indicate to the right then, we will times our number 4.93 times 10 to the negative 3 power. When we have an extremely large number with the implied decimal place here past the last 0, we only want a single digit to the left of the decimal, so we will move 10 powers, 3 here, another 3, and another set of 3 for a total of 9 powers of 10. And to write an equivalent then, our number in scientific notation with 1 digit non-zero to the left of the decimal of 2.876 times 10 to the number of decimal places, or powers of 10 that we moved that decimal point, which was 9, to give us an equivalent expression in scientific notation.